In this lesson, we are going to show another example of application of the probability rules. In particular, we are going to study a case in which the events are independent. The problem we are going to solve is the following. Assume the likelihood that any flight on Delta Airlines arrives within 10 minutes of the scheduled time is 0.68. We select 5 flights from yesterday to study. What is the likelihood of all 5 of the selected flights arrive within 10 minutes of the scheduled time? B. What is the likelihood that none of the selected flights arrive within 10 minutes of the scheduled time? And C. What is the likelihood at least one of the selected flights did not arrive within 10 minutes of the scheduled time? Here appears the word likelihood. This is just another way of asking you probability. When you don't want to say probability, you say likelihood. With the information we have, I can separate here several events that are independent. It would be reasonable to think that the fact that the first flight arrived within 10 minutes of the scheduled time is independent of the event that the second or the third or the fourth or the fifth flight arrived within 10 minutes of the scheduled time. So I noted that there are here 5 events that can be considered independent. So I'm going to say that A sat 1 is the event that the first flight arrived within 10 minutes of the scheduled time. And A2 is the second flight arrived within 10 minutes of the scheduled time. And A3 will be the third flight arrived within 10 minutes of the scheduled time, etc. A4 will be the fourth flight arrived in the scheduled time, and A5, the fifth flight arrived within 10 minutes of the scheduled time. And also have the information that the probability that each of these flights arrives within 10 minutes of the scheduled time is given by 0.68. So the probability of A1 or the probability of A2 or whatever of these probabilities will be equal to 0.68. So I'm going to take note of this, and I'm going to say that probability of A sub I, and this I here could be whatever of these 1, 2, 3, 4, or 5, is equal to 0.68. So the probability of each of these events will be 0.68. This is the information that we get from the problem. And from this information, we are going to solve a first question. What is the probability that all 5 of the selected flights arrive within 10 minutes of the scheduled time? So let's solve first this first question. We have that the probability of AI equals 0.68. But now I'm thinking about this event. All 5 flights arrive within 10 minutes of the scheduled time. The question is, what is the probability of A? But remember, to describe events in mathematics, we have a few words. And one of these words is and. So instead to ask what is the probability of all 5 flights arrive within 10 minutes of the scheduled time, I'm going to ask this question in a different way. What is the probability that the first flight arrives within 10 minutes of the scheduled time, and the second flight, and the third flight, and the fourth flight, and the fifth flight arrives within 10 minutes of the scheduled time? So instead of writing probability of A, I will be writing the probability of A1 and A2 and A3 and A4 and A5. And we know that when we have independent events, the probability of A and B, let's type here the formula for the probability of A and B when the 2 events are independent. Probability of A and B will be the probability of A times the probability of B. So in this case, the probability of A1 and A2 and A3 and A4 and A5 will be the product of all these probabilities. Will be the probability of A1 times the probability of A2 times the probability of A3 times the probability of A4 times the probability of A5. And each of these probability is 0.68. So it will be just 0.68 times 0.68 times 0.68 times 0.68 times 0.68. You can just solve this, or just writing in this way 0.68 to the power 5. That is equivalent. So if you do that, the answer is 0.1454 rounded to 4 decimal. This answers the first question. Let's answer now the second question. What is the probability that none of the selected flights arrive within 10 minutes of the scheduled time? So for answering this question, let's type here the new event. None of the selected flights arrive within 10 minutes of the scheduled time. Probability of none of them is the probability that the first flight doesn't arrive within 10 minutes of the scheduled time, and the second flight doesn't arrive within the 10 minutes of the scheduled time, and the third flight doesn't arrive within 10 minutes of the scheduled time, etc. So it will be the probability of no A1 and no A2 and no A3 and no A4 and no A5. And again here we have independent events. And this will be just the product of the probability of no A1 times the probability of no A2, probability of no A3, etc. until the last one. If we know the probability of A1, we also know the probability of no A1, because if we know that the probability of A1 is 0.68, the probability of no A1 will be 1 minus 0.68. Let's type this here. The probability of no I, wherever I is, I between 1 and 5, it will be 1 minus 0.68, and this is equal to 0.32. So let's type here 0.32. So actually we have the probability of each of these events. For that reason, this probability of none of the selected flight arrive within 10 minutes of the scheduled time will be 0.32 times 0.32 times 0.32 times 0.32. So multiply 0.32 5 times. This is equivalent to type 0.32 to the power 5. So just do that, and the answer will be 0.0034. This answers the second question. And now the last question. What is the probability at least one of the selected flight did not arrive within 10 minutes of the scheduled time? So let's solve this question. The question is related to this event. At least one did not arrive on time. But you see that when I say at least one did not arrive, actually means the same to say not all of them arrive on time. So actually we're going to find the probability of no A. And we know the probability of A, the probability of all of them arrive on time. From the first question, the probability of all 5 arrive within 10 minutes of the scheduled time, we computed already, and the answer was 0.1454. That was the answer of the first question. And we know that the probability of no A will be just 1 minus the probability of A. So it will be 1 minus 0.1454. And the answer here is 0.8546. And this answers the third question. And with this, I finish the explanation of this problem. Thank you.